Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have k plus 2 square root divided by k plus 2 is equals to 1, and we solve this problem for all the values of k. So for this we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move towards the solution of this problem. And in the first method, here we use the nice rule of radicals. You know about that. If you have any number a, we write it as into the form of product of two radicals. We write a as square root of a multiplied by square root of a. So in the same pattern, we write the term k plus 2 as in the form of k plus 2 square root multiplied by k plus 2 square root. So according to this rule, we write the given equation as in this form. So here first you have k plus 2 square root divided by, this is k plus 2, we write this k plus 2 as k plus 2 square root multiplied by k plus 2 square root is equals to 1. And now you see here this k plus 2 is cancelled out by this k plus 2, and we get here the remaining values are 1 divided by square root of k plus 2 is equals to 1. And further in the next step, we move the term from left hand side to the right hand side. You see here it is divided by here. When we move it into the right hand side, it is multiplied by 1, and we get the remaining values are k plus 2 and its whole square root. So further in the next step, we need to remove the square root sign from left hand side, and for this we will uh, take squaring on both of the sides. And when we apply squaring, it will be written as this 2 and this square root are gone, and we will get here the square of 1 becomes 1, and here we obtain k plus 2. Further in the next step, we move the term plus 2 from left hand side to from right hand side to the left hand side, and it will becomes here 1 minus 2 is equals to k, and we easily get the value of k is equals to minus 1. So this is the value of k which we get here in the first method, and now here in the next step we need to verify that is this value of k be the solution, or is this value of k be the extraneous root. So for verification of this value of k, we need to copy down given question statement here, and the given question statement is square root of k plus 2 divided by k plus 2 is equals to 1. And here we substitute the value of k is equals to minus 1 into the left hand side, and it will be written as this is square root of minus 1 plus 2 divided by minus 1 plus 2 is equals to 1. And in the next step, we need more simplifications here, and we have minus 1 plus 2 becomes here square root of 1 divided by square root of 1 is equals to 1, and this implies that 1 is equals to 1. This shows that both of the sides are equal. It means that the above value of k is equals to minus 1 is satisfied our given question statement. So finally we have the solution set of this problem is k is equals to minus 1. So this is the only one solution which we get here in the first method. And now we again solve this problem for second method. And now for second method, we need to copy down given question statement. Here it is k plus 2 square root divided by k plus 2 is equals to 1. This is our given question statement, and here in the second method, we move the term k plus 2 from left hand side to the right hand side. It is divided by here, and when we move it into the right hand side, it is multiplied by 1, and it will be written as k plus 2. And now here in the next step, we need to remove this square root sign from left hand side, and for this we will apply squaring on both of the sides in this form. So this 2 and this square root are gone, and we get here k plus 2 is equals to, here in the right hand side we will use here the nice algebraic formula. So according to this formula, we write k plus 2 square as k square plus 2 times of k into 2 plus 2 square. And now further in the next step we have, this is k plus 2 is equals to k square plus this is 2 times 2 becomes 4k plus this 2 square becomes here 4. So we move all the terms from left hand side to the right hand side, and it will be written as k square plus 4k plus 4, and this is minus k minus 2, and this whole equation is equals to 0. And in the next step we have, this is k square and 4k minus k becomes here 3k, and 4 minus 2 becomes here plus 2, and this whole equation is equals to 0. So further in the next step here we need more simplification. And you see here our given equation will becomes in quadratic form, and here we just use the quadratic formula to solve this problem. So here in other words we just apply here the factorization technique to solve this problem. So for this we break the middle term, as this is 3k, we write it as 2k plus 1k and plus this is 2, and this whole equation is equals to 0. So in the first two terms we will take common k from here, and when we take common k we get the remaining values are k plus 2, and here we take common 1 and we get the remaining values are k plus 2, and this whole equation is equals to 0. So further in the next step we have, further you see here we need to take common k plus 2 on both of these two terms, and we get the remaining values are k plus 1, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write k plus 2 is equals to 0, and the second case is we write k plus 1 is equals to 0. And from here we get the value of k is equals to minus 2, and from here we get the value of k is equals to minus 1. So here we get there are two roots of the given equation, and now in the next step we need to verify that is these roots be the solution or is these roots be the extraneous root. So for verification of this we need to copy down given question statement. Here it is k plus 2 square root divided by k plus 2 is equals to 1. So here in the first method we already verified that k equals to minus 1 is already satisfied our given question statement. So this is the solution of the given equation, and now here we need to verify the second value of k. So when you put k equals to minus 2 here, it will be written as minus 2 plus 2 square root divided by minus 2 plus 2 is equals to 1. And here we have this implies that minus 2 plus 2 becomes 0, our 0 form is equals to 1. And we very well know about that 0 over 0 form is usually called that it is indeterminate form, or in other words we say that it is undefined. So if our left hand side is undefined, this means that both of the sides are not equal, and if both of the sides are not equal, this concludes about that the value k is equals to minus 2 is not satisfied our given question statement, and we call that k equals to minus 2 be the extraneous root of the given equation. So this is the extraneous root, and here we cannot get any value of k. Here we have just only one value of k which is satisfied our given question statement, so that we have the solution chart of this problem is k equals to minus 1. This is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.